Here we have the limit as x approaches infinity. And as I look at that then, if I were to try and think about what's going to happen, the numerator is going to go to infinity and the denominator is going to go to infinity. So I've got a couple of options. Actually, with the square root in there, I don't think we want to use L'Hopital's rule. So I'm going to use what we did when we first learned about limits, and that is to multiply numerator and denominator by 1 over the highest powered x in the denominator. If we always pick the highest powered x that's in the denominator, we will have a term in the denominator that won't be 0. So let's see what we get. We have the limit as x goes to infinity, and 1 over x squared times x squared will be 1 plus, I'm going to rewrite this as x to the 1/2 so that I can combine that one. So it would be x to the 1/2 over x squared. And so that would be 1 over, I could move the x to the 1/2 down and subtract it. So it's going to be x to the 3/2 in the denominator. Now I'm going to distribute this 1 over x squared in the denominator. The x on top will cancel with one of them on the bottom and leave us 3 over x. And then we have minus, and x squared over x squared is 1. So now we are ready to take the limit as x goes to infinity. We know with this specific one, fixed numerator, denominator going to infinity, the fraction is going to go to 0. And same with this 3 over x, fixed numerator, denominator going to infinity, the fraction is going to go to 0. So we have left 1 over -1, which is -1.